Yeah. So if we remember, just to quickly demonstrate what we just discussed now regarding the different type of evaluation measures we could have in WEKA. So my data is already loaded like we did yesterday. So now what we need to do next is to, of course, select our classifier. Our favorite classifier is the lazy one. So if you want to use neural network, they are all here. Just click function. You have all of them here. This is multi-layer perceptron. So you want to use decision tree. You go down to the tree. You see them all there. This is tree. So, and also of other support vector machines, they are inside the function SMO. So for now, we are using the IBK. So yesterday, we used the percentage splits, whereby we use this percentage split, whereby we used 70% training, and then the remaining is going to be the testing. So we started, and then our model is built. We already discussed yesterday how to do the optimization. You need to change your parameter because the default is 1. You have to try 3, 5, 7, and just to be sure you are getting the best result possible. And also, don't forget, you need to check your distance measure. This is Euclidean distance. Can you try shape equation? Can you try the Manhattan? So we set this to 70%, and then we run, you say start, it will build the model for you. I say you should go here, try to play with the K, which is very important, the hyperparameter for KNN, there are 2, and then you also play with you clear the distance measure. You see the different options that are actually available to you. You can play with them, Manhattan, Minkowski, and host of other. Once that is done, now, what we want to now show is the cross validation we just displayed to you. You know, I just said that we have 2 ways of dividing the data. The holdout method. This is the one where you divide into 70 and 30. What if I want to divide it into 3? This one can undo the first 2. So divide your data into 3 on your Excel file manually. Take away the 50% you want to use later. Put it in another Excel. Now put the original one now in one Excel and upload it. And then you can calculate what percentage is going to be. So maybe 70%, 30%. You have your result. If you want to supply the third one, the third partition you kept with you, just go here and say, supply the third set. Now you upload the third file now. Remember, you divided your data into 3. The first 2, they are taken care by this particular option, percentage split. The third one has to come in later after you have built the model. Just say supply the test set. It will bring it a new file. Open your file as we did earlier. Select the file, and then the data can come in. Then you can test. When you click start, it will use the new file you have supplied to run the third category. That is when you are dividing your data into 3: training, testing, and validation. Now, the second option of partitioning data, the cross-validation. This is where you just select how many folds. This data is like almost 600. I can use 10-fold for it, that's fine. Or I want it to be 5-fold, 5 only. You set it here, and then you click go. So it's going to run your experiment using 5-fold. You can see that we are getting 97% accuracy. In the direct partition holdout, the maximum we got was 93. Why? This is why some people prefer to use this cross-validation, because it's trying to use every member of the data as both training and testing at least one time. So every member will participate in testing one time. You divide data into 5 portions. 1 portion used for testing, while the other 4 used for training. Next time, this one that was used for testing will become training. You do that until each of the partition has been used for testing. Then you find the average. So that is why some reviewers like that you use cross-validation, because they want to know how all the data sets are performing, not because maybe the one you use for 30% is a little bit not good, that's why the result is down. So that's why sometimes I advise my students to use the two. Use 70%, 30%, report your result, use cross-validation, and also report your result. So if the reviewer is interested in cross-validation, he has it there. If you want the other one, the two are there for him to choose from. And using the two, there's nobody to penalize you for that. Except if you have a paper that work on your data earlier, you want to compare, you have to make sure you use the one you used before. Maybe you use 70-30. In addition to that, you can also put cross-validation beside it as your new additional work. It's even better for you because that gives people a better idea that, okay, with this one, we might even be able to get better results. So this is how the cross-validation do work. Now, so with this now, I think those things we just described, and you can see some of this is the confusion matrix I was explaining to you. This is the confusion matrix. So you can see it here. See, let's use this direct one here. You can see A, B, positive, negative. This confusion matrix. It's good to always show your confusion matrix. These are other measures. For classification, the most important is the accuracy. What's the percentage? Tell us the percentage. Tell us the confusion matrix. Then these are precision, record that I told you using formula. Then more detail on this, kindly refer back to our earlier videos. So this is on WEKA, as this case may be. Thank you very much.